So good morning everyone, I'm Nelson Compay. I will be presenting my research paper 2 as one of the requirements in course subject RES 290OL or research technique for online under Dr. Dante Silva. So the title of this research paper is Development, Fabrication, and Evaluation of an Adiabatic Cooling System for Air-Cooled Chiller Unit to reduce the condensing air temperature and increase the chiller coefficient of performance for energy savings. So let me introduce you first about the air-cooled chiller. So in industrial and commercial cooling, the chiller is one of the most used, especially the air-cooled chiller, which uses ambient air as a medium to dissipate heat from the condenser to the environment. So according to Martinez, air conditioning system are being installed in building to improve the quality of life and comfort. So heating and cooling account up to 50% of the final energy consumption demand in the Europe. In a building, chiller consume a substantial amount of energy and can be significantly increased operating cost when the efficiency of the air-cooled chiller decline as the outside temperature rises. So as per the Philippine Energy Efficiency Act of 2019 or the Republic Act 11285, set forth plan to increase energy efficiency and reduce consumption. It is declared that the state is committed to institutionalizing energy efficiency and conversion to lead an energy efficient and practical life, formulating, developing, and implementing energy efficient policies. So with this study, focus on developing an adiabatic cooling system to increase the coefficient of performance of air-cooled chiller units that reduce the surrounding ambient air temperature and subsequently to reduce the energy consumption for the chiller operation. So this is the statement of the problem. The main objective of this research is to develop, fabricate, and evaluate the effectiveness of an adiabatic cooling system by integrating it into the condenser side of an air-cooled chiller unit, which reduces entering ambient air temperature to the condenser, minimize the effect of solar radiation to the condenser coil, and increasing the coefficient of performance and lower the energy consumption of the chiller. So specifically, the study will address the following. First is to design an adiabatic cooling system to increase the coefficient of performance of an air-cooled chiller unit by lowering the condensing temperature using a water mist that reduces the ambient air temperature and a wire mesh that optimize the effect of water mist and lower the radiated heat of the sun. Second is to evaluate the effect of heat transfer from the sun and ambient air to the condenser coil of the chiller by determining the actual ambient air properties and coil temperature before and after the installation of the adiabatic cooling system. Third is design a spray nozzle and wire mesh that produce the effective amount of mist with lower volume consumption of water and proper size and material of mesh to give optimum shading effect without affecting the design airflow rate of the condenser. Fourth is to develop a logic control or for a different mode of operation of the system that can logically adjust and adapt based on the demand and need of the equipment and the operator. To improve the logic control that can be integrated into the chiller equipment and the BMS chiller plant control system. So lastly is to determine the energy saving by evaluating the effect of the adiabatic cooling system on the chiller COP, installation cost, and operation cost of the system. So in this slide, you can see the summary of the related literature. So for adiabatic cooling, it is a process to give free cooling to the condenser, entering air temperature also by using the system, which can save up to 40% of electricity than conventional cooling tower, according to tech target contributor. So for heat transfer, this is the effect of heat from the sun radiation and ambient condition to system, or the thermally activated energy conversion. For the nozzle and wire mesh, so nozzle design plays a big role for the efficient water atomization, especially the nozzle orientation, which has a great effect in enhancing the COP of air-cooled chiller. For the logic control, the logic control plays a vital role to achieve a highest beneficial effects of adiabatic cooling system. One of it is by integrating a condensing temperature control or CTC control with misting equipment to increase COP of the chiller. Lastly, the energy savings. So increasing the COP of the chiller to reduce operating costs means conserving of energy by decreasing the power consumption and losses of the equipment. So this is the summary of related literature. So for adiabatic cooling, an insulated system where adding and removing of heat is negligible. For example, humidifying an air under adiabatic condition so that heat energy is neither added nor removed. For heat transfer, a transfer of thermal energy from one system to another, or this is the impact of ambient temperature on an air-cooled refrigeration system. So, means nozzle and wire mesh. So it is the heart of a adiabatic cooling system that needs good design and fabrication, especially the nozzle, for water atomization at the inlet of the condenser. For the logic control, so a complete system to analyze and execute the data based on the sequence program or controller to receive input and output data for automation. So for energy saving, so reducing the operating cost of the equipment without sacrificing its performance. So this means a reduction in energy consumption. So this is the conceptual framework. So the process was divided into 4 phases, and each phase has its detailed procedure that need to be followed. The first phase is or the initial stage of the design. The initial stage of design will be conducted by creating a process flow diagram for a adiabatic cooling system. The output of this step will be used to create the next step, which is the creation of piping and instrumentation diagram. This diagram will be converted to the initial stage of creating a construction drawing. This one. The data from step 1 to 3 will be used in step 4, which is the engineering design and calculation, from which the output of the step 4 will be used to finalize all the details from step 1 to 3. So this one. So this cycle process is repeated until all the design parameters and drawings are finalized. So after completing the mechanical parts of the equipment, the next step is the design of electrical components, especially its control system and its sequence of operation. This one. Then followed by the creation of electrical construction drawing. So at this point, we are now ready to make the bill of quantities that we will be using for the procurement of the construction material. This one. So the output of phase 1, which is the construction drawing and material, this will be used in phase 2, which is the fabrication, installation, and functionality test of the adiabatic cooling system. So if the result of the functionality test fails, if the test is fail, it need to revisit the design of the whole system and repeat the procedure starting on step 1, this one, until the test got satisfactory. So once the equipment passes the functionality test, we are now ready for the third phase, which is the testing and data gathering. So various mechanical and electrical parameters not limited to air temperature, humidity, airflow rate, and power consumption will be measured to use as a variable for data analysis. For the last or fourth phase of this research, we will now analyze the effect of an adiabatic cooling system on air-cooled chiller based on its economic viability. So the energy saved on the operation of the chiller will be evaluated compared to the installation and operation cost of adiabatic cooling system. This one. So the specific objective 1 will be addressed at this area. So specific objective 2 will be addressed at phase 3, specific objective 3, this specific objective 4, and lastly, the specific objective 5 will be addressed at phase 4. So this is the matrix of methodology. So all the data, material, instrument, and equipment will be delivered and installed at the selected workshop area. All design, calculation, and drafting will be performed by the researcher using engineering software and computers. So all the data will be collected using engineering software and instrument, and it will be analyzed using various statistical treatment. That's end my presentation. Thank you for listening.